Hello and welcome everyone. My name is Arpad Jorzic, and this is our online AWS community of practice meetup. First of all, I hope you are all doing fine and healthy. And as you remember, we started our journey as an AWS community back in February, and since that, well, a lot of things have changed actually. The world turned upside down as we got a nice pandemic, which was impacted our plans heavily as a meetup group, no question on that. It took a while to figure it out how we can switch to fully to online meetups. But after the vacation season, now I'm happy to inform you that we are back officially in a fully online form and we won't stop. As always, I would like to tell you that if you have feedbacks or any ideas on the content, what you would like to hear or see in the future, please let us know. And if you want to join us as an organizer, it's also possible. Please send us an email and we will discuss the details. And about the session of today, we will talk about AI, we will talk about smart applications, and of course, we will talk about a lot about AWS as well with our speaker, who is Darko Mesaroš from Amazon Web Services, and I do hope that you will enjoy it. So that was it for a short intro, and Darko, now the stage is yours.
Thank you very much. I guess I can do some share thing. 1 second. It's been a while. I can request control, I guess. Or does it work like that? Oh, no, wait. Aha. Am I sharing my screen right now?
Yes, you do.
Ooh, perfect. Give me 1 second. I just want to make sure that this is all good. Cool. So, hello and welcome, or your state. Welcome to this talk about how to build smart applications without building a machine learning background. So first of all, én beszéljük magyarul kicsit. So I come from Szabadka, from Serbia, where half of my family is Hungarian, hence Mesaroš. But I don't speak well enough. I've been basically, I never learned Hungarian as a young person in my life. So I can understand when people talk Hungarian, roughly what it is about. I can answer some basic things, but I can also pronounce Hungarian and read Hungarian, but I cannot speak Magyarul that well. So before we get into the details, what is this going to be talk about? So there's a lot of talk about serverless and machine learning and all those things. And how can those things actually benefit you or your application? How can you get this fancy new thing of machine learning into your application, right? So what are the steps you need to do? Is it difficult? Do you need a bunch of servers to do that? Do you need something, train your models? Do you want to deploy a fleet of containers to do those things as well? Yeah, you can. But there's better ways to do it. And today, basically, I will explain those things a bit. Now, I'll get to who I am, but I'll try not to make this as a sales pitch. I want to show you what technologies exist out there. But I think at any point, I'm not sure if we have an ability for people to ask me questions, because I am looking at this thing. Is there like a chat function? In any case, I'm sure that there is some sort of a way for you to ask me questions. Feel free to do so at any time. And this is live. This is not pre-recorded, so I guess we can move along. So why are we here? Why are you actually here? Why are you here listening to me talk about machine learning or AI? Well, AI and machine learning exists for a long time, much longer than people actually think. But just in the past few years, people have been really hot about it, right? Everybody's talking, AI and machine learning are the next big thing, and AI and machine learning will get me a lot of things in my application. I can improve what I do. It's going to make all the things I do much better. Oh yeah, but you need a PhD degree. You need a doctorate in mathematics. You need a lot of things. So that was kind of there was this big gatekeeping towards machine learning to just very smart, very intelligent people, or people who are basically have studied for machine learning, how to train their models. They would require huge, server farms to actually train their models and all those things. But actually at AWS, our mission is to put machine learning into the hands of every developer, right? So if you have, I don't have it here, but if you ever had a chance to look at things such as the little toys we have, the Deep Racer or the Deep Lens or the Deep Composer, all of those things that kind of teach you machine learning or help you wrangle machine learning through literally touching those things. So we want to make ML basically democratized, right? Give ability for everybody to benefit from AI and ML, not just learn AI and ML and build, like train or build AI and ML models, but also use AI and ML. So it's very important that even if you have no experience, have no knowledge, you want to be able to actually take the capabilities of these applications and implement them into your own applications for your own benefit. And I'll give you a few examples here how things work. So the AI ML stack. So there's a bunch of things. When we talk about AI and ML on AWS, I remember a few years ago, it was just one thing, right? There was no, when I joined Amazon in 2016, I think none of these services existed. Yeah, none of these services existed on AWS. Nobody was talking about SageMaker or Recognition or TensorFlow or Gluon on AWS. Nobody was talking about that. And a few years ago, people started talking about that, and people want this. So at AWS, there's a whole bunch of things available on AWS. And when you look at this, you go like, oh, okay, Darko, what is this? I came here to learn something to help make my application run faster. I don't want to know about Keras and Gluon and TensorFlow. What? Yeah, exactly. So that's why we're going to talk just about the top part of this entire fun stack or the entire ML stack, where we have basically just the things we need to implement in our application. These are some things called AI services. Now, this is the top level of our AI services of our machine learning stack. This is available to every developer. No ML skills required, right? So, for example, you as a customer say, hey, here's an object, here's a picture, tell me what's on this picture. We can tell you with like Recognition, right? Hey, you want to build a conversational app? Absolutely, go for Amazon Lex. So these are services that exist there, basically APIs available out there for you that you can use to empower your applications with serverless. So not serverless. I just did a talk on serverless with machine learning. Yes, sorry, my 5th time on camera today. Without a lot of knowledge behind it. But let's talk about who I am and why should you care. I'm really sorry I never got a chance to meet you in person. I believe your first meetup was in March this year in Budapest, and I was supposed to come, but I couldn't. So my friend comes, Sinisha. So yeah, maybe when this entire plague situation goes away, I will be able to come to Budapest and actually see you all in person. So my name is Darko Mesaroš. I am a developer advocate based out of Berlin, Germany. What is a developer advocate? Well, it's a person who talks to yourselves, developers, engineers, all the smart people who use AWS, and I get your feedback. I get your feedback on what you do, how you do it, how can we make things better for you, and basically try to be your voice within Amazon. And I'm actually been working for Amazon for the last almost 5 years now. So 2016, February, I joined. And I've started in premium support, moved from premium support to solution architect to specialist solution architect. And now I'm a developer advocate trying to educate and entertain at the same time. Now, because we only have like an hour today and you would like to hear this bald man speak a bit more, do check out my Twitch and YouTube channel. I do a lot of content there. I basically do 2 streams a week on some various technical topics. So if you want to check it out, please go there. I'm very happy to have you as a viewer. And also do follow me on the social medias because I post a lot of questionable things. Okay, so let's move on to the actual thing. Let's move on to the important parts of these machine learning services and what they are. And let's start, first of all, with data and users. How can we use AI and machine learning to help your users of your end application? And how can we help you actually work with data in a more smart way? And by the way, this is just going to be a reel of some services we offer. I'm not trying to sell these things for you, but I just want to make you aware what exists, and then you can see how they can fit in your application. Because what's important? It's important to understand discovery is important. That's the word. Yes, you need to understand what exists there, so you do not invest your time and effort into building things that you potentially don't have to. The goal of this entire presentation is do not reinvent the wheel. It may exist already. So, Amazon Personalize. This is an amazing feature. So, Amazon Personalize is basically a service that enables real-time personalization and recommendations. So if you have a customer base, right? So you can deliver high-quality recommendations, right? So if you have like a customer base that use a specific set of products, like let's say you have an e-shop or a bookstore, imagine that, have an online bookstore, and you have a bunch of customers that would like to do certain things or buy certain things. And one of the things that Personalize can do is actually use machine learning to generate recommendations for that customer. And it's not just a generic recommendation or personalization engine. You actually get a chance to train models on your customer data. So you can take your anonymized, or well, to an extent anonymized customer data, identify features, do something like hyperparameter selection, train those models, optimize models, then host those models within AWS, and basically give you this customized, personalized API that your customers can actually use to get better recommendations on your application. What is very important, I actually had a discussion with a customer a long time ago on Personalize. When you use something like Personalize, you actually need data. You need identifiable data on your customers. So this customer I talked with, they wanted to use Personalize to recommend blog posts or something like that. Yeah, blog posts to their customers who visit their website. Right. The thing is, they have no way of identifying customers. There's no such thing as a username, a login, or anything. So it's just random people joining a website. And they thought that Personalize will basically just recommend the best thing for those people. It doesn't work that way. So we actually have to feed data into Personalize to actually recommend something for that specific user. And here's a real-time example, right? So an event happens. There's a recommendation request to the service, right, to the web server. The web server actually makes an inference query to the Amazon Personalized API. The recommendations go back to the service, to the web server, and then your web server actually spits back those recommendations to the customer. Very simple, very easy. You don't have to do a lot of things besides provide customer information or data sets that can actually be used to train this personalization engine. Fraud detection, this is relatively new. This was released back in, I think, on reInvent last year, so almost a year old. But basically, it's a fraud detection model. Now, Amazon.com, as you may know, is a big platform. 20 years of experience, right? We run Amazon.com, and we have 20 years of experience of detecting fraud, because you can imagine a lot of people try to fraud some things, right? So basically, the fraud detector provides you with a tailor-made fraud detection machine learning models for online events. So for things such as e-commerce orders or account registrations. So it's not just a matter of statistical detection. It actually does it's a machine learning model that can detect potential fraudulent orders or fraudulent transactions and fraudulent account registrations, right? So the way this works, you actually simply upload your customer data and to train the fraud detection machine learning, and then basically configure some decision logic. There is some decision logic, some rules you can set up, and it can definitely help you. Now, it's not just a matter of fact of giving your own data and then that works. It actually boosts your own data with the Amazon, with our fraud data we had in the past, so it can actually help you massively inside of your it can help you improve that machine learning, optimize that machine learning model. And this is kind of how it works, right? So, check out a purchase, it goes to a website, and then actually the website is the web server actually checks or triggers an API. It's just an API. It triggers an API towards fraud detection, and then fraud detection takes that information and gives it a score, says, okay, it's approved, it's not too bad, or it says, you know what, this seems fraudulent, then you can go ahead and do that back to the customer. Because, hey, how do you do it now, right? So detecting fraud is very important, especially on e-commerce right now. Another thing coming from Amazon.com is forecast. Now, forecast is, as the name says, it's basically it's a forecasting engine. So it has the ability to kind of predict what certain things need to be sold when. Here's an example where forecasting is important, right? For things such as weather, crop prices, patients, ads, etc. Right? These are kind of the places where forecasting is very important. And where also is forecasting very important? Amazon.com. So way back when, so when Amazon.com started, the way we did forecasting was basically traditional statistical methods. So, we knew that, hey, everyday household products will be sold quite often, but maybe there's some products that are specific to seasons. So we get to, kind of forecast those things being more sold. Or like, hey, there's a new, there's like a regional/national demand thing, or we know which products are not selling quite well. But all of a sudden, with the use of machine learning, we started detecting that, hey, we got more improvement in accuracy in forecasting those things, right? We use deep learning and machine learning that we can actually detect or forecast what things are going to be sold. So how does this work actually? Well, same as other things. You provided a lot of data. You provided historical data, related data, some item data, and then you built this data set on top of Amazon forecast, and it trains this machine learning model for you. And then basically you have this private forecasting API, this API tailored for you and your use case. And then basically you can just call that API from time to time to, hey, you have a store. Let's say you have a store or a warehouse or something like that. You want to forecast what items will you need for the month of September, right? You can run Amazon forecast against specific data sets and get a suggestion what could be potentially what could be the potential requirement for that store. So that's a really great way to use it. All right, moving away from the people/data approach, and let's talk about a very interesting service. Let's talk about code. And I'm a developer myself. Well, actually, I'm an engineer. I did a lot of engineering work, and I love code. And you may ask yourself, what does code have to do with machine learning, or how can machine learning help my code? Well, there's this little neat service called Amazon Code Guru, which actually uses machine learning, as everything here, to actually perform your code reviews, right? So it does. It's a service that basically runs machine learning powered code reviews against your code, your application code. So you have your application code, you commit it to a repository, actually make a pull request to a repository, and then Code Guru will actually review that code and give you suggestions how to improve that code. Now, it's not just a standard linter and saying, hey, this is a bad practice, but it actually takes a lot of the expertise we at Amazon have for the last 20 years, right? And we've been writing code for a long, long time, and it actually does analysis of your code. So it understands what certain piece of code has what impact and how can it do it. Also, I'm sorry, go back. The profiler actually can measure what improvements could you introduce into your code to increase performance of your code. So unfortunately on this one, it's currently, I think, only supported with Java. So if you're not using Java, womp womp, yeah, I know. And it's a bit of a pricey service. So at least in my opinion. Now, do check this out if this maybe works for you, but it's just be careful on the pricing as well. So yeah, here's how the review process goes. Again, make a change, make a pull request, and then a reviewer and Code Guru actually has a review of your code, and it basically augments the human code review. It's not there to replace your code, your buddies who look at your code. It's just there to augment it. It can basically say, hey, some piece of your code could be better. For example, things like APIs, right? Hey, maybe your AWS best practices are not up to snuff. Maybe some concurrency stuff, resource links. If you put some sensitive information, because there are people who hard code passwords into their code, so that could be also like code effects, because it can actually mine a lot of data to understand if there's like a potential code defect. And the profiler is the thing that I said that it actually can find the expensive lines of code. When I say expensive, it basically can find pieces of code that cause the most latency or cause the most utilization, or basically having the most expensive piece of code inside of your code base. So that's a very cool thing. And actually, in real world example, at Amazon.com, we used Code Guru, or well, the service that became Code Guru. I think this was way before Code Guru existed. But Amazon Prime Day, right? It's the biggest selling day of Amazon.com. compared to year before, thanks to Code Guru and the improvements in the code we did, we had much more CPU utilization and the good kind of utilization, and we also decreased cost in running the infrastructure because the code was, well, much more better because of the profiler actually reviewed a lot of the code out there and told us, hey, you have a lot of expensive lines of code. And how to do this? Basically, you can plug in Code Guru into your GitHub repository where you can actually review the code there. So it is pretty cool. All right, moving on. Text. Text is a very important thing, and a lot of things when it comes to machine learning are boiling around text, and you'll see why. Textract. Now, when this came out, people were telling me, "Hey, Darko, you guys just reinvented OCR." Well, no, it's a lot more. It's not just reading text off a page. It's basically, I would call it OCR++, right? In essence, you can pass it on a lot of things. So it's not just, hey, here's a page with some text on it. Please let me know what the text on that page is. But no, you can actually give it a table. It will extract that the table exists there, right? It will also do like form extractions. It will understand what it reads. You can pass it on financial documents, healthcare documents, government documents, of course, applicable to, I guess, to the United States, at least for now. But it's able to, again, thanks to the power of machine learning, to extract text and extract information from those kinds of documents. So it's not just a blank reading of a document, of a paper. It's able to intelligently understand those things. And again, it's an API call. Comprehend. Oh, this is a very neat service. And I'll show you actually later a bit of a demo as we go along. So Comprehend is a really neat service that gives you the ability to actually understand the text. It's not just read the text, it helps you understand. So it comprehends. So think of it as you have a campaign, you release something new, and all of a sudden, Twitter goes crazy and everybody starts tweeting what you're doing. How do you analyze Twitter? Do you hire a horde of people to gather each tweet and parse the text and read it and give it a rating of 1 to 5? Well, Comprehend can actually understand the syntax, get key phrases, and understand the sentiment. So if somebody sends a bad tweet about you, Comprehend is able to flag that. It's able to understand, hey, that's a bad comment about me. So you can do like, I think back when the Winter Olympics were, or last Winter Olympics? Yeah, the last Winter Olympics, I believe. Yeah, they used Amazon Comprehend to parse a stream, basically a full-on stream of tweets about the opening of the Olympics to get the people's sentiment of what they think about the Olympics and how does it open. So that's a really great way to get mass things at scale because it's very difficult to do with people. So very cool service, and I think I'll show you an example later on in one of the demos. Yeah, when it comes to languages, it supports English, French, Spanish, German, Portuguese, Italian. Yeah, that's it. And Spanish. I said Spanish, yes, that's it. Okay, Kendra. Also a relatively new service, which is very expensive, but it's very cool. So what is the biggest, I'm not sure how many of you work in a big company, but I worked in big companies. I used to work for, way back when, for AT&T. I work for Amazon right now. And one of the biggest problems I have in that entire environment is searching for stuff. How many search locations do you have in your company intranet, right? Oh, you want to find a specific how to do something, or maybe a HR document, or that and that, or you want simple information. When is the day off, or when is, I don't know, when is this specific holiday in our company, or whatever, right? So many things to search. How about if we can use the power of machine learning to kind of rethink that enterprise search? So what happens with Kendra? It uses NLQ, or natural language queries. So it understands what you ask it. So if you go to Kendra and say, hey, Kendra, when is, I don't know, who's the director of this company, for example? And Kendra will not find you the directors of this company. Kendra will say, hey, the director of this company is X, Y, and Z. Or when was this company founded? X, Y, and Z. Or who's my HR contact? Person and person. So it actually uses like machine learning to emphasize this. It's not just a search engine. It uses machine learning to understand what you're asking it and get you more information. But for example, where can you get that information from? Well, here's a bunch of things. You can basically just take an S3 bucket, dump a whole bunch of text files in there, PDFs, HTMLs, all the things in a S3 bucket, and tell Kendra index that. And then if I did this example a long time ago, I don't have it ready right now to show because it takes a while for it to set up, but I would throw like a bunch of Wikipedia pages inside, and I would ask it, Kendra, what is the capital of Hungary? And it will say just Budapest. It will not point me to a wiki page of Hungary. It will say the capital of Hungary is Budapest. So it's really cool. And as you can see, there's a lot of connections here, just to databases, to Exchange servers, to Zendesk and Jira and Dropboxes, and a whole lot of different places you can store file and have this central index where you can actually set it up like this, say, hey, this is where my data sits, and I can share it. For example, hey, look, I can connect to SharePoint. Wow. And then you're looking for something. Hey, what's the support desk Kumo? Or what is the support desk blah, blah, blah. It is able to understand what kind of question you may ask it, and it will get you the proper answer. So really, really neat service. One caveat. It's 4,000 euros a month. So it's very expensive. So it's not for everybody. So I would not launch this in my small to medium business, because having $4,000 a month, I believe that was the price last time I checked, for a search function. Yeah, I'll skip. But if you're a big company, if you're looking for an amazing search function, Kendra is your thing. Oh, fun. The visual things, image and video. Again, if you ever done a hello world with machine learning, it's usually about recognizing, is this a number 3 or this is a B, or is this a hot dog or is it not a hot dog? So having services connected to these things is just a given, right? And most of the time, customers use something like this well, inside of their applications. So, for example, recognition. It's a service that actually recognizes or does image recognition or image and video recognition against, well, objects you give it, right? So it can do a bunch of things. I can say, hey, you know what? It can detect faces, detect text, and all those kind of things, right? So, but on top of that, you can actually do more things. You can actually set up custom labels. I had an example on this. I think I took it down, but oh wait, let me try actually. So I'm gonna open up my browser somewhere. Let's call it this one, and then open up AWS console like that. I want to log in, and I want to show you how I have recognition set up. I've actually set up recognition custom labels to detect certain things. Now, wait. And then please give me my corporate account. Yes, thank you. I've set it up to detect custom things, right? So it can detect things like I'll actually show it to you right now. So let me go to recognition, and I want to share this browser window. One moment. Where is this? Stop sharing. Share something more. Share. Where is the thing? This one. You should be able to see my Amazon recognition console right now. So recognition basically gives you the ability to say, hey, here's an image, right? Oh, that's a person, right? That's a car, that's a skateboard, that's a wheel, a couple of general things. I've actually created a custom label. I'm not sure it's still if I have it deleted or not. I may have. No, I did not. Interesting. Oh, cool. So if anybody, I'm not sure how popular that is in Hungary, but burek is a food, right? It's a pastry that it's very popular in the Balkans. We eat it in Serbia, in Bosnia, in Turkey, in Greece, and in Bulgaria, all over the place. It's basically a pastry that it's pastry with cheese or with meat, and burek is something very specific to where we come from. And I trained a custom label to detect if something is a burek or not. So I have a data set here of a bunch of, oh, I don't have this images. No, it's gone. I basically got about 26 images of bureks, and I've basically labeled, hey, this is a burek, this is not a burek. So for those of you who do not know what burek is, burek is, yeah, it's basically this. So that's burek. It's a lovely if you ever are south of the border, come to Serbia or any of the former Yugoslav countries or anywhere in the Balkans, get a burek. So I've trained recognition to actually detect burek. It would take like an hour for me to train with 26 images here. And I was able to just throw it an image of something and ask it, hey, is this a burek or not? And it will say, no, it's not, or yes, it is. It was relatively successful. So that's a really neat way you can do it. Let's actually have a look at more recognition, and I want to show you a few things. It can do facial analysis, right? So it can analyze a face. But actually, let me find my face. Darko, I think there's a Darko here. Yeah, there we go. So I'm going to let it recognize my face. So it says it does look like a face. Appears to be male. That is very much correct. Age range 22 to 34. At the bottom, well, at the top end of that spectrum, definitely. Not smiling. I tried to smile. I'm horrible at smiling. Appears to be calm, absolutely. But here's the thing. It's sure that I have a beard. That's very important. But it says I do not have a mustache. I'm being discriminated against. So that's not good. I do have a mustache. But one important thing, you will never use recognition like this. You don't go to a console, upload the picture, and check what it is on. What you actually do, you actually make a request. It's an API call. You just take an object, a byte object of this picture, pass it on to recognition, and you get a response, something like this. You get a JSON response back that bounds a box where the face is, age range, smile, etc., etc. You get all of those things here with their confidence values, and then you take that and do something with it. So everything here you see, everything, this entire console is literally for demonstration purposes. You will never use this thing for I will not detect celebrities on my web browser because, yeah, it's fine. I will use this as a request and get a response, and who this is, and maybe a URL and those kind of things. So pretty neat. Okay, back to sharing something else. Yeah, share, this is fine. This one, cool. So that's recognition. Perfect. It's a very neat thing, very useful services, especially a lot of people who want to do some image analysis. I have had a customer who would post some images on their own platform from users, but it would use recognition to detect potential sensitive images, like it will detect nudity and those things. Right. Okay, one more thing, natural language. And this is what machine learning was made for, to detect or process natural language. Now, processing natural language means either understanding what you're saying or producing what you're saying. So the thing that produces what you're saying is Amazon Polly. Amazon Polly is a service that basically it's a text-to-speech tool, but it's not just the traditional. If anybody of you had like a Atari ST or an Amiga in the 80s, it would have this very robotic text-to-speech voice. Amazon Polly actually uses machine learning to produce lifelike voices, right? It uses 59 concatenates and 150 neural lifelike voices, right? It does 29 languages are available, and it uses deep learning to do these things. So it's sometimes of course you can notice that it is a fake voice. It's not that perfect, but it uses this specific I forgot what the name of the language format is. There's actually syntax that you can use with Polly to augment it by adding like swallows and stops and breaths, and you can make the language, the voice sound much more natural than just like a robotic voice. Like it's not just Amazon Polly use cases. You can make proper pauses and stops and breaths and rhythms of talk as well. So it's really, really cool. Transcribe is the opposite of that. Transcribe is basically a voice to text. It uses, again, machine learning to actually convert what I say to a whole bunch of text. And it's not just, again, it's not the old Windows 98 speaking to a microphone and it shows up on screen. It actually uses a lot of things. It's able to identify who's speaking. It's if you, for example, let's say you have a meeting, and you can use Amazon Transcribe to actually collect different people who are talking what they are talking. So it's able to actually identify who said what and put it in a lovely transcript. Then you could take that transcript and push it onto, for example, I don't know, Comprehend, and Comprehend can actually get this, get the lovely, get the sentiment of that entire meeting. Was it positive? Was it negative? And that's actually, I don't have this prepared, but Amazon has a service called Amazon Connect, which is like a virtual call center. And within that virtual call center, you can actually set up machine learning features that you can, if somebody calls that call center, right, and you have an agent and a customer talking, the call is being recorded. This call is being recorded for educational purposes. But in this case, it's being recorded because it's going through Amazon Transcribe, which can actually analyze, or actually all the machine learning services can transcribe and analyze the phone call that you can, in a dashboard, in real time, see if there's a potential angry customer on call on the phone, or bad sentiment or something like that. So these kind of things are used for those as well. And again, it's just an API call. It's nothing complex. Lex, so if you're a fan of having a end-to-end conversational engine, Lex is kind of the thing for you. If you like making those chatbots or bots that will buy plane tickets or order something, Lex is that service. Again, it uses machine learning to detect what's being asked from it and give proper answers. So similar to like how I can't say her name. Amazon Echo, the lady in the Echo, says basically it works in a similar way. So there's a bunch of, hey, here's how you would like to book a hotel, right? You say, hey, I would like to book a hotel. Then the bot says which city, and then you say, okay, then bot process, okay, what time? So it's not a human interaction bot, but it is very much able to understand what you want, what you say back to it, and respond with more questions to get more information from you. So it's very, very cool. Again, an API. Which is great. You don't have to train your own bots. Okay, a bit of a weird thing right now. Augmented AI. Amazon Augmented AI, or A2I. When we talk about AI, we usually either think it's like, oh, we're just going to have everything in AI. AI is just so good, it just does amazing things. And I'm going to just make an API call to an AI service and it just works. Well, it doesn't work that way. Sometimes you have to combine your workflows. You have to combine your AI workforce and people workforce, because not everything can be detected by AI, at least not now, right? So sometimes for some decisions that AI makes, you need a human review. For example, if you remember my face and it says, Darko doesn't have a mustache, I'm 81% sure Darko doesn't have a mustache. If you are 81% sure that what you're about to drink is coffee, would you drink it? You wouldn't, exactly. You would want somebody to check it out. So if AI is not certain that something, the confidence score is not in the high 90s, then what can happen with A2I, you can actually direct those kind of things to your workforce. So here's a great example. A client sends input data. A model does something, or machine learning does something, it makes predictions, whatever, right? Then what happens? High prediction or high confidence models, like something, oh, I'm very confident that in this picture Darko has a mustache, and that goes to your client application immediately. That's fine. But if it comes with 82% or low confidence that Darko has a mustache, then actually that has to go to a human workforce to review, right? Basically, this goes to a bunch of people that can, say, yeah, it's review and answer the questions. Now, by them answering these questions, you can actually improve your ML and AI model in the future to help it work better, and then store those results back in S3. And again, client application, again, gets that information. There's a slight delay, but that's a fair point, because it's better to have a slight delay than to, predict that Darko doesn't have a mustache, right? So this is kind of how it works, right? Now the building blocks approach. Why am I talking about building blocks? Because I've shown you a whole lot of things today. I showed you a whole lot of Legos. I showed you a whole lot of services, APIs, things you can plug into your application. And that's the whole point. There is no overarching general purpose AI that will do everything for you, right? You have these little small building blocks that you can plug into your applications, or basically build your applications against them. Here's a great example. You have some audio input. That audio goes to S3, right? Triggers the Lambda function that picks up that S3 and gets that audio file to Amazon Transcribe. Amazon Transcribe converts that call into text. That text goes to Comprehend, and the information from Comprehend goes to Amazon Athena, which is our our engine to throw a lot of analytical data into, and then you can analyze that data in Amazon QuickSight. Maybe get your audio analysis or your sentiment analysis. How many people who have called you have been angry or have been positive? Media analysis, for example, right? There's a web UI. People upload pictures or media there. Lambda functions picks that media up. It all goes into a orchestrated step function, basically it's a more complex workflow where a step function will recognize objects, videos, and get that information back. It will transcribe the audio from that video file, and Comprehend will basically make a small summary or key phrases or tags based on that video. And then Elemental services, which are nothing to do with AI, but Elemental can transcode those videos in multiple things. This is basically what YouTube can do and automatically tag your videos. So yeah, this is kind of a thing. And then again, force all of that information into Elasticsearch and just go back and have a fully searchable media analysis solution. And it's actually available there if you want to have a look at how this would function. Amazon Connect. I mentioned this virtual call center, and this is how it actually looks in a diagram model. So a customer calls Amazon Connect. The audio is streamed using Amazon Kinesis to Lambda functions, and that call is actually going to transcribe, Amazon Transcribe, we hear a lot about it, to the API. And the information coming from that is actually going back to a Lambda function and S3, and that information is being processed through a DynamoDB table to an agent, right? So then you can have AI that will process the text doing something like Comprehend will understand, hey, what's the problem, what's the syntax, what is the sentiment. Translate will translate into multiple different languages, so you can implement a lot of different things here. And again, all of these things are building blocks. Those yellow or those green blocks are all AI services that you don't have to worry about. It's an API call away, right? And here's a great example from my colleague Danilo Poccia. Danilo Poccia built this serverless application. It's a small serverless chat application. It's called Positive Chat because it will take chat and use Comprehend to detect, hey, is that a negative thing you're saying? And it will say, hey, please say something else. If you say something bad, it will say, hey, this is only a positive chat. Please say positive things. It also uses translate and a whole bunch of things. And actually, I'm going to show to you how this works. So if I go back to this thing and then go to Microsoft Teams to share more things, share, where are you guys? This one. I will go to GitHub. Danilo Poccia, if I can find it. Danilo. Yes. So this is his application, and if I open up, it's also available on GitHub. It's open source. You can check it out as well if you want to see how does it actually work. How inner workings are. So here's the positive chat. Super exciting design. Very 2020. CSS all over the place. You like that. So if I do Darko, my user, and let's call a room. How are we going to call it? Let's call it who. Right. Start. It's basically going to chat room, and you can actually join this room. If you go to this link right now, any of you can join it, and this is all publicly available, so just please be careful. If I say hello and send the message, it's going to send a message, right? But it can also translate messages. So if I say, let's translate it to Hungarian, oh, it does hello. If I say, how are you, right? How are you? If I send, it's going to send the message, but it's also going to translate to hogy vagy, right? So it's possible to have like a chat or have something like this. Now, if I write something bad, how can I do it? I hate it here. Will it do something here? Yes, please find a better way to express this. So it used actually Amazon Comprehend to say, yeah, your sentence is very negative. It's bad. Please use a better way to, if I do, this could be better. Hit send. Again, that's not good. Okay, wow. It's really forcing me to say something else. What can I say? It's okay, I guess. Yeah, Rendben van azt hiszem. Rendben van azt hiszem. Now, you can confirm is this good Hungarian or not. I am not as competent enough to say Rendben van azt hiszem. Is this sufficiently good enough? But yeah. So yeah, and you can translate to any of the supported languages on the Amazon Translate. But basically, this thing was built from the a lot of those building blocks I showed you and talked about today, and it's just a simple serverless application that had no hello Banza. There's no requirement for you to basically understand machine learning or be a machine learning expert to build something like this and benefit from machine learning such as this. Again, it's not perfect. You know, translations can be iffy, right? But in general, it is a very cool little piece of magic that you can implement into your applications. So it's very cool. All right, really useful. Oh, Najon Hasnos. But does it really? Okay, yeah, it does properly accent hello and Najon Hasnos. No, super. Okay, stop sharing, and once more, I'm going to go back to my. Oh, there's some questions. Published question. Burek sounds mess. Oh wow. Okay, somebody commented in chat. Burek is only with meat, and that's like a thing where we come from. Actually, that's a thing in Bosnia. Burek. There's a big discussion about that. Burek in Serbia, we eat burek with cheese, we eat burek with apples, with all different things, right? We call everything burek, but in Bosnia, the only thing that's burek is the thing with meat, and there's a whole discussion about it. Yeah, I can go all day about it. Okay, cool. One more slide left. Thank you very much for Köszönöm szépen. I've had a pleasure to deliver this talk. This is my first time delivering this talk, so maybe you haven't noticed that, but I did enjoy talking about AI services. I do strongly believe they have a place in everybody's application. You can benefit from them quite immensely, especially because they're very easy to implement and use. Again, no requirements for you to be a massive data scientist or mathematician to kind of get benefit from AI already. So thank you very much for your attention. I really did enjoy delivering this talk to you, even though it was virtual. Hopefully, when this entire plague situation goes over, I can come and meet you in person. And yeah, feel free to follow me on all the things. And yeah, I am very much open to questions. If anybody has questions on this thing here, I'm not sure that. Yeah, you can kind of put Q&A, I guess, on Teams, and that's it. Also, if you have questions you don't wish to ask in public, feel free to reach out to me on LinkedIn and Twitter, and I'm happy to answer questions there as well. So just drop me a message there as well. In the meantime, I'll finish my coffee. That's it. Okay, well, I guess if there's no question, Esther, are you still here?
Yeah, we have no more questions.
Okay, if there are no more questions, once again, thank you very much for attending this online virtual variant of this user group meetup. It was a pleasure to meet you all to an extent, and thank you, Esther, and thank you everybody from the user group for inviting me to talk. Hopefully, I get a chance to come again and do more things.
Thank you. Bye.
Thank you. Bye bye.